Hello dear students, very good morning. Here we are going to start the third chapter of our physics 10th. Dear students, in this chapter we have to understand about machine. First of all, there is a question arises in our mind. What do you mean by machine? What it means, meaning of machine? Simply, machine is anything, any device which do your work easily by applying less effort, by applying less force. If you easily do a work, that thing, that device which you use is called as machine. For example, if you want to open a nut, then you will use wrench. It will help you easy way to open that nut or tie that nut. Okay? It means without the wrench, you are not going to do that work easily. That will be very tough for you to do that. Even sometimes you will never able to do that work. It means here wrench is what? Machine. If you know that many people use car jack, okay, to lift car. A simple boy, a small boy, even you, even I, anyone, any person, by using car jack, lift his car easily. But without using car jack, if I say go and lift the car, it will be a tough work. Means machine is a device which makes your work easy and less time taken to do that work. Okay, simple. It is a device which helps to do your work easily. Okay, let's understand here the definition of machine. Basically, what machine do? In this definition, these words are: a machine is a device by which we can either overcome a large resistive force, that is called as load, at some point by applying a small force or effort at a convenient point and in a desired direction, or by which we can obtain a gain in speed. Simply, it has explained you what does machine do. Machine do your work faster, means by increasing in speed. Machine do change the direction of your work by applying force at a convenient point. Okay. Machine do increase the work, increase the effort by applying or multiplying your force. Okay dear? So basically machines do 3 or 4 things. First, it multiply the force. I will explain it how it multiply the force. Okay? First of all, understand. It multiply the force. It increases the speed. Okay? It changes the direction. And the fourth point, you apply, you use the convenient point where to be used a machine. Okay? So dear, machine do 3 things basically. That is to increase the effort, means multiply the force. You have to just learn multiply the force, increase in speed, change in direction. And these 3 things I will explain in end. Okay? Now come to the point, some terminology related to machine. Dear, let's suppose that a work to be done, or a work is, you have to do a work. Simply, what will you do? You will apply force. The force applied by you to do that work is called as effort. And force applied by machine to do that work is called as load. Simply, you are applying a force on machine, that is called as effort. nut, you will apply some force on range. Dear, it means you are applying effort to range. Okay, and range is applying some force to open a nut, that is called as load. Okay, the resistive opposing force to be overcome by a machine is called as load. Means some of you, if you will ask, sir, what is unit of load? Basically, load is a force, so its unit will be also Newton. Dear, effort. The effort applied on the machine to overcome the load is called as effort. It means it is also a force. Simply, if you just apply a force on a range, that will be called as effort. You are applying force on the range, that is called as effort. The range is applying force on nut. Okay, that force is called as load to overcome that. Okay, so here a terminology, next terminology is called as mechanical advantage. What it means? Simply it is a ratio of load and effort. Means how much force you are applying is called as effort. What to be done to do a work, how much force required, that is called as load. Okay, the ratio of load to the effort is called as mechanical advantage of a machine. Mechanical advantage, that formula is load upon effort. It simply means it gives you an idea about how much times a force is applied, how much times a force is increased. Okay, how much times of your effort is increased or decreased. Okay, this will give you that idea. Okay, velocity ratio. Since load and effort has the same unit, that is Newton, so it has a more unit here. It is very important. Whole this chapter will move around this topic, mechanical advantage. If you are not knowing mechanical advantage, you are not going to understand any topics of this chapter. Because on the conclusion, we will reach to this point only. What will be the machine? What should be the mechanical advantage? What will be the velocity ratio? This will be asked to each and every point. So it is the heart of this topic. Okay? Mechanical advantage means load upon effort. You have to always remember in your mind. Load upon effort. Load upon effort. Effort, the force which you are applying. Load, the force which to be overcome. The work to be done. That is called load. Okay. Velocity ratio. The term velocity ratio. It is easy. The ratio of the velocity of the effort to the velocity of the load is called as velocity ratio of the machine. Simply, velocity ratio is equal to velocity of effort upon velocity of load. There will be a technique to remember it. It is just opposite to each other. Okay. Mechanical advantage, load upon effort. Simply, you have to just make a prepare in your mind. Say mechanical advantage, load upon effort. Why? Velocity ratio, effort upon load. Velocity of effort upon velocity of load. It is just opposite to each other. Here load upon effort, here effort upon load. I hope you will be able to learn. Okay. Now I am going to find another formula of velocity ratio. This is in the form of velocity, while this is in the form of displacement or distance. Okay. Let's suppose that dl and de are the distances moved in the same time t by the load and effort. Let's suppose that you are applying an effort, you are applying a force on something to do. Okay, and it is just moving some distance in a particular time. Then load will also move to some distance in a same time. Let's suppose that time is t. So what will be the velocity of load? Velocity of load will be distance traveled by load by time. Okay. Similarly, velocity of effort will be distance traveled by effort by time. So its ratio will be, as we are going upon T upon dl upon T. T and T will cancel out, and the remaining is velocity ratio is equal to dE upon dl. Means distance traveled by effort upon distance traveled by load. Simply there will be a next definition to here, that what do you mean by velocity ratio in the distance moment? So you will say that the ratio of distance traveled by effort to distance traveled by load is called as velocity ratio of machine. Dear student, there is a very important point you should learn about this, that velocity ratio is a fix for every machine. Whatever be the machine, when it is designed, its velocity ratio will be that time fixed. After that, if a machine is designed, that time its velocity ratio is fixed. After that, it is not going to change. It will be constant forever until this machine will work. So it is not going to change time to time. It will be fixed when it is designed. So it is always fixed value. Means if you are saying that velocity ratio of a machine is 1, it means it always will be 1. Either it is ideal case, either it is practical case, its ratio will be always 1. Dear, I hope you are able to know that. Now come to the point that now I am going to take a next point, that is mechanical advantage. How mechanical advantage make types of machine. Okay. According to mechanical advantage, there is a many types of machine. Basically, 3 types of machine. Okay, I am going to make it clear. Okay. For example, if mechanical advantage, we know that mechanical advantage is equal to load upon effort, as I am explaining here. It means there will be 3 cases here. The first case is that mechanical advantage might be greater than 1. I am taking another point also, velocity ratio greater than 1. Let's suppose it may be a second case that mechanical advantage less than 1. Let's velocity ratio will be less than 1. If mechanical advantage, I will explain later why velocity ratio will be less, why velocity ratio will be greater. Mechanical advantage is equal to 1, it means velocity ratio will be equal to 1. Okay, what it means, and then I will fragment the types of machine. Okay, first of all, I hope that you might understand that if mechanical advantage is greater than 1, it means that load is greater than effort. Load is greater than effort. Then it will only be possible that mechanical advantage of a machine is greater than 1. Here, for example, load is 6 and effort is 2. Then it will be only the mechanical advantage be 3. For example, let's suppose means for mechanical advantage to be greater than 1, always load should be greater than its effort for a particular machine. Dear, it means that you are applying less effort and doing more work. Means you are applying 1 Newton force and getting 5 Newton force. It is very easy. Here, it is. It means it is doing a force multiplier. Force multiplier. I hope you are able to understand. Force multiplier means you are applying a force of 1 Newton and you are getting a force of 5 Newton. It means it is multiplying a force of effort is greater than load. In here also said means here what is going on? Here it is here load is this, but you are applying greater effort and work is going very slow, which means force is less. Now when mechanical advantage is equal to 1, it means that here mechanical advantage is equal to 1, it means load is equal to effort. It means it is changing the direction. There is no increase or decrease of forces here, so there is no change, only change in direction. So I hope you will understand about this. Here it is a force multiplier. Force multiplier. It is a speed multiplier. This is a change in direction of effort. Change in direction of effort. In the next class, I will move the relation between mechanical advantage